Good day, everyone. Welcome to today's Impact webinar, Powering Europe's Digital Future, Great Transformation, and Data Center Collaboration. My name is Raylin, content producer at Leader Associates, and I'm delighted to be your host. Across Europe, AI adoption is accelerating, data center investment is surging, and the energy system is under growing pressure to keep up. The question is no longer whether grid transformation and digital infrastructure are connected. They clearly are. The real question is how Europe can turn that independence into an advantage through smarter planning, stronger coordination, and long-term investment. And that's exactly what we are to explore today. And our webinar is structured around 4 keynote presentations, each followed by a short Q&A session. So please feel free, if you have any questions, submit your questions at any point using the Q&A box, and we'll get to as many as we can. This webinar is also part of our lead-up activity to the Future Grid and AI Data Center Europe Summit in Frankfurt, 28th till 29th September 2026. And we are bringing together 500 senior leaders, great operations like Tenit, 50Hertz digital infrastructure players, including Microsoft, Data4, plus investors, policymakers. Our goal is to better connect power and computer infrastructure for the AI age, promote joint projects, boost investment, and develop new infrastructure solutions. So we are sincerely looking forward to seeing you in Frankfurt. And here is the room we are put together for today. We are delighted to be joined by Paolo Bertoldi from the European Commission, Mark Benigno from ADF, Neil Kalita from NTT Global Data Centers, and Christina Rentil from Aurora Energy Research. Together, they will bring perspectives from policy, power systems, digital infrastructure, and energy markets, offering a unique view of how Europe's digital future. So first, we are delighted to welcome Paolo Bertoldi. Paolo is a senior expert and project leader at the European Commission, where he specializes in sustainable energy efficiency, and the energy consumption of data centers and AI. As Europe seeks to balance digital growth, energy security, and climate ambitions, Paolo has been at the forefront of many of these discussions at the European level. Today, he will open our webinar with a keynote entitled A Green Digital Vision, Co-Creating Europe's Future Grid for the Age of AI. Hello, thank you for joining us. The floor is yours.
Much for the invitation. I'm an advisor now to the European Commission and also a consultant on energy impact of data center and AI in Europe, particularly. I've been doing this analysis for a couple of years. I'm going to present my latest finding based on what is available from several reports and paper around. So basically, I'm going to speak about the energy impact of a data center at the global level, and then I focus on Europe. So as you know, the data center represents about 1.5 of the global electricity consumption, around 415 terawatt-hour consumption. And most of analysts agree that this will more or less double by 2030. But there are also some analysts who forecast a 4-time growth up to basically 1,800 terawatt-hours. But most probably, this is not a likely scenario due to several constraints, financial constraint, energy constraint, component constraint, that I'm going to give more details later on. For your information, I have a lot of slides. I go through them rather quickly, but I'm available to share my slides on request. There is my email at the end. So the latest study from the IA, released just 1 month ago, confirm these trends. Basically, you see from 415, now we predict in 24, now predict 485 in 2025, and a growth to 2030 at 950. And this will represent more or less 3% of the global electricity consumption. The electricity consumption is driven not only by data center. The increase will also be driven by electrification of building industries and transportation with electric vehicles. It's also important to notice the high capital investment that will be needed, not only for the data center, but also for reinforcing the grid and increasing the power supply to data centers. You can see basically that the global consumption is dominated by the United States, which is more than double the European Union. China is also bigger than the European Union right now. And if we look at the base case for 2030, we see that the European Union will not even double, maybe in the high range, in a high growth scenario will double, while the United States will more than double, and China will even grow and faster. So the forecast, the European Union will have an impact from AI, more data center dedicated to the AI and more traditional data centers, but not as big as in the United States and China. Let's go to the next slide, which I think, can you move to the next slide, please? Okay, this is a slide on the US market. As I say, this largest market. What is interesting to see that there are some regions in the United States where there is high demand for additional data center, in particular Northern Virginia, which has already a high share of electricity consumption in data centers, so kind of congestion and not much power available. And the moment natural gas is dominating energy source in the United States, followed by renewable, nuclear, and coal. And this is, of course, not very good from a climate change point of view, from greenhouse gas emissions. So if we focus now on the European Union, as I said, we're going to grow from 2024 to 2030. And as I said, this growth is concentrated in 4 countries, which are already dominating. Germany, the largest one, representing already 18 terawatt-hour, between 18 now, most probably even 20 terawatt-hour. France, Netherlands, Ireland, and Denmark, and Italy. I just highlighted Luxembourg because if you now compare the data center consumption in this country to the electricity consumption, you see that Ireland is outlier, is indicated in the slide 18. Some analysts say that is up to 25% already. So a very large share of electricity produced in Ireland is, or imported in Ireland, is used for data centers, and this creates a lot of problems. And basically, there's no additional capacity to add the data center there. But already you can see that compared to a European average of 2%, Germany, Netherlands, Denmark, and Luxembourg are already above this average. So this indicated there are a lot of data center, and additional data center in this country may be problematic. Next slide, please. Now, when we look at in further details, the European location data center, we know that financial capital are attracting most of the data center that are already installed, and there's still a lot of demand. And we have 5 cities dominating. One is not in the EU anymore: London, Dublin, Paris, Frankfurt, and Amsterdam. And Frankfurt has grown a lot in recent years, is almost equal to the installed capacity of London. And then we have some Tier 1 cities, in particular Madrid, Milan, Zurich, Warsaw, which are growing and are predicted maybe even to grow faster. In particular, for example, Milan, Italy, is a large economy. There's not been much investment in data center, and now there is a kind of catch-up. So is going to grow. Okay, this is showing basically the installed capacity, the new capacity added in 2025 is already, you see, is more than what has been in the past. So more gigawatt hour are requested so in megawatt hour. So altogether will make it almost 1 gigawatt hour. And while in the past, whenever it was building adding a data center, it was, having half of the data center empty, so not online, and gradually growing. Now everything that is constructed will be occupied by, in particular in the co-location situation. So the so-called vacancy rate is very low. It means that there is a strong demand for using data center space, in particular in the co-location situation. So a very dynamic market, and this will increase investment because there are opportunities to further expand the supply. So inevitably, the energy consumption that is predicted to increase will add greenhouse gas emissions. In particular, in the European Union, we have a goal to reduce emissions at 2030, minus 2055, at 2040, and to become climate neutral at 2050. So we have to reconcile the expansion of the data center industry, in particular the AI industry, which we like to have it, not to be left behind and rely on US mainly, but also on China, and also to be able to keep our data in Europe, to have sovereignty of our data. So, and how to make this compatible with a low carbon emission future. Please, next slide. So this is a global picture again of the emissions. And what is important to already note that the growth in emission is not as big as the growth on energy. And this means that there will be investors are looking all the time for low carbon solution, being renewable, being nuclear, in particular small nuclear reactor, and most probably as a transition fuel, natural gas. And basically, this is what drives the AI power demand. Next slide. And traditionally, data center at the service with CPUs, having per chip consumption about 100 to 200 watt, at the server level 500 to 1 kilowatt, and the rack level from 1 to 5 kilowatt. As you know, inside data center, there are many racks. Now, with the introduction of GPUs, the consumption per processor is basically a factor of 20 increase. And this means that basically a rack that I would say was in the range of 1 to 5 kilowatt now will be in the range of 60 to 100 kilowatt, but there are already projection of racks up to 1 megawatt. So the power density inside the data center is increasing, and there is also a dramatic increase in efficiency. So the combination of more capacity and increase will drive this higher consumption, but not as high as if we would have relied on old CPUs. So what we can say that yes, the energy will demand, but the system will become as efficient as possible. And this, you can see basically the prediction of consumption per racks coming from NVIDIA GPU architecture roadmap. And when the new GPUs, the Feynman type, they consume about 4 to 6 kilowatt. So these racks will become 1 megawatt. So we have a factor almost 1,000 increase in power density. I mentioned before 200, we can go up to 1,000 this factor, because we still have traditional racks in 1 kilowatt. So, and this is only in 15 years. A completely there's a revolution inside the data center, and I can show you what's happened in the next slide. And so basically, you can see the power demand at the level of rack, and this translates also in a campus, which traditional data center campus in Europe was between 1 and maximum 50 megawatt. Now we see new campuses coming online more than 100 megawatt, and there is some request for a gigawatt campus. The so-called gigafactories. So this is basically a large amount of energy demand concentrated in a capacity, bringing a lot of issue of getting the power to the data center and providing this power. And this will somehow limit the expansion in some area because there is no more capacity, or there is no network to bring the requested power to the data center. Next slide. I think we can. I can just say very quickly that it's not just the AI data center for developing AI model and training. Then is also the traditional cloud industry, which is moving to GPUs as these are more efficient. Of course, all these request a large investment that can also be a barrier to new entries, and the cost of capital will be very large for GPUs. But we see a trend of more and more companies coming in the market proposing GPU as a service, offering GPUs for cloud. And so this all, as well as the traditional AI, will increase the power demand of the data center industry. Inside the data center, we see a transformation. At this power intensity in the racks, the traditional air cooling is not anymore possible. By the way, is also less efficient. The liquid cooling, in particular, the solution adopted will be direct liquid cooling, making available a lot of waste to be recovered. And this is something that is very important in Europe. There is a lot of emphasis whenever there's a designer data center, but also location, try to locate it close to a place where there is a district heating network that the rejected heat can be reused by data center, lowering the global carbon footprint of the data center. Now we come to consideration on the energy and in particular the power distribution. So the traditional AC distribution inside the data center will be replaced by high voltage DC, 800 volt power distribution. So this will revolutionize the system. There will be a lot of DC converter, and again in efficiency, less losses. Regarding the power problem that is not available, and in particular we see this development in the US, data centers are looking more and more for on-site or behind the meter power solutions that can support the high power requirement, sometimes complementing what is available. So if I have a 300 megawatt new campus, I may request maybe 150 megawatt from the grid, and then maybe providing the rest with on-site generation. The traditional model of looking for renewable is still valid, but is more and more constraints in renewables because we know they are available in some area and not, for example, where a data center would like to be constructed. So this is a factor and a choice. Will the data center industry move where there is the nuclear energy or the renewable energy, for example, in France, in Northern Europe, in Scandinavia, which have a combination of different renewables as well as nuclear, or south of Spain, always will stay located in Frankfurt, Milan, Amsterdam, where there is limitation in power, and so there is more need for on-site generation. Of course, if this on-site generation in the short term can only come from gas, because there are no other technology, but there is big hope that a small modular reactor will also be a solution to provide power, maybe power in a number of data centers in the range of 100 to maybe 500 megawatt. In the United States, there are a lot of investment, a lot of attention. There are already PPAs for purchase for future electricity produced by SMRs. While in Europe, the permitting, the rules may be more different. So we see already also the co-locations of data center close to power station. This is another close power station, or where there are already connection and a transmission line suitable to bring the required electricity, or basically close, for example, to nuclear power station in the US. In particular, say in Europe, the issue of getting the power and the power requests that are reaching the TSO and national level are exceeding what is available. So there is already a waiting list, and it's suggested maybe that when there is a new design of a data center, not to request the full power, but gradually increase it. Because if I want 200 or 400 megawatt, could be a problem if I start to requesting 50 megawatt, because I know I start with maybe 1 or 2 home in my campus. That could be facilitating, and also allows the company that manage the grid to manage and plan the investment requirement. Next slide, please. And I think I can very shortly conclude. As I said, there is still a strong appetite to have more and more renewables, because the industry would like to, has made commitment to reduce the greenhouse gases to reach carbon neutrality. We know that traditionally big hyperscaler are the largest purchase of renewable energies, in particular through PPAs. But as I said, it's very difficult to add a large amount of renewable in our system in a short time, in particular because of their geographic location, the inadequacy of the current transmission grid in Europe, which will require large investment to be enforced. And there is also the desire to having more and more matching the renewable all the time, rather than annual renewable matching at 24/7 carbon-free supply. And this will trigger certainly investment also on battery energy storage, large one, that will not be anymore just to make the data center operate in a blackout situation for some minutes. It will be maybe much larger to allow charging the batteries when the renewables are cheap and available, and then using the battery energy storage system to run the data center for hours. So a strong increase in storage capacity, which can also be used then to allow some flexibility with the grid, some support to the grid in certain period when the data center is not operating full capacity. Just next slide, just very quickly saying that beside the energy, there is also attention to the water consumption, in particular if evaporation is used in cooling towers, so it's preferred to have a closed loop circuit. Some area where there are scarcity of water may be not a good solution for new data center, wherever there are large rivers, lakes, or even the sea. This could be a better solution, but attention should be also placed to the water consumption. And this is another a problem sometimes for the location, when the local population is afraid that water used for homes or agriculture may be taken away by the data center and may create a local opposition to the siting of new data center. Beside the large data center that will the gigafactories for training, there will be many more smaller facilities close at the edge, installed in factories, in cities, in university, hospital, whenever there is the inference of data centers. So we also will see a growth of smaller facility, 1 to 10 megawatt, may be located also where there are 5G base station. They have to have low latency for application like autonomous vehicle, industrial application. And this could also be powered by local renewables and offer local support to the distribution grid with their batteries. Next slide again. In Europe, we have, as I said, a number of regulation that are focused on improving the efficiency of data center. It is a common reporting scheme. Very, very soon there will be also a rating scheme. And in addition, to this, there is also a strong interest to have more AI development in Europe. So the dilemma and the difficulties is how to reconcile the desire to expand the AI industry capacity and development in Europe with our environmental and carbon constraint. And there are a lot of discussion with the AI industry, with investors, and with utilities to see how this will develop in Europe. So it's very important not only to look at the grid issue, the power, but also looking at the local and local situation where whenever there is the need to site a data center, is also important to look at what is available in terms of power, how can we reuse the waste heat, how to minimize the water consumption, and how to win the local community support. Because very often data center investors find opposition by local population, which believe that the data center will increase the local energy price because they will put constraint on the grid, they will take away the water. So it's important to show that this will not happen, and on the contrary, the data center can offer heat for heating the buildings, can develop, create jobs locally, and can support the community. So despite all these difficulties, the investors are predicted to be large, but in particular in the US, it seems that there is no problem to attract the needed capital, in particular for the infrastructure investment on site. So the needed GPUs and a system to distribute the energy inside the data center, the storage and the energy storage and the on-site generation. While most probably on the grid side, there is less clarity how to who should invest, who should pay for the grid reinforcement, and how to and for these, I think there is a lot of discussion now ongoing in Europe on the model in which our grid can be updated to cater for more electricity, not just, as I say, coming from different sectors, and in particular for large demand for AI-driven data center. The conclusion, I think, just to summarize again, the energy will increase. It will not dramatically increase. It will only be 3% of total energy, but still in absolute term, it will be large. The data center architecture will change due to the high power density. Attention should be kept to the emission and find solution which will use electricity with low carbon content. There might be a dash for gas for on-site energy production, which is not the best solution, but mostly is the only one available in the short term. And we hope that in Europe, maybe we can limit this expansion. Water can be a problem. And as I said, we have a policy already leading to high efficiency data centers. So this is, and also try to increase the amount of renewables. We should not forget that AI will also have a positive impact on emission in other sectors, will make buildings, transportation, and our factory much more efficient. So I think with this, I can go to the last slide where there is my email. So I thank you for attention. Sorry for overrunning. There is much more material in the slide that I did not present. So in case you are interested in getting a copy of the slide, you can contact me by email, and I'm pleased to share you or to give you further delay in a separate call. So thank you very much again for the invitation. And if there are any questions, I'm happy to reply.
Thank you very much, Paulo. Thank you. And you mentioned about the global energy demand and to the regional trends and you mentioned about the power, the GPU roadmap, and you talk about the water consumption and the policy frameworks. Yeah, I think that was an excellent overview of the challenges and opportunities facing Europe as it seeks to align digital infrastructure growth with its broader energy and climate objectives. I'd like to explore a few of those themes in a little more detail. We all know that the European Commission has set an ambitious goal to triple data center capacity within 5 to 7 years. Yet, in some of the Europe's established markets, we know getting a great connection can take up to a decade. So, from your perspective, what is the single most important structural change needed to close this gap?
As I said, it can require a large investment. So, and most probably in particular on the electricity infrastructure should be a combination of public and private investment. The industry has to do its own part. And of course, because they will require a lot of additional energy, but in particular, there should be models where other investor in the grid can, through tariff and charges, can recover the cost. As I said, but we should not put all the blame and all the cost of reinforcing our electricity system to the data center operator, because there are other uses that will, as I said, will increase energy consumption. So there should be a strong strategy. At the European level, we are also discussing how to make the data center also supporting the grid with the additional batteries that they plan to install, with the on-site generation, which can also be, whenever it's not fully used by the data center, can be used for exporting energy from the data centers. And we hope that the industry will continue to invest also in renewables in Europe. So it's basically investment, but it's investment not only for GPUs, for constructing the data center infrastructure inside the data center in the campus, but also looking at the energy system, both production and distribution, transmission and distribution of energy.
Yeah, I know. And of course, where this growth happens matters just as much as how it happens, I think. So, in some regions like Nordics and the parts of Southern Europe have more available grid capacity and are growing faster as a result. So, what policy frameworks or governance tools could help Europe get this shift more deliberately rather than leaving it purely to market forces?
I know that many governments in Europe are keen in attracting data centers. And obvious location, as I said, could be the Nordics, which have an abundant renewable supply, some nuclear supply, as well as a cold climate, which help at least on the cooling side. The Spain and Portugal could be very interesting for renewables. A lot of solar development are happening right now in Spain, so there is again. But we know that maybe in that area, the grid needs reinforcement. We know that there's been a major blackout in Spain recently. But however, the industry is also willing to be and wanting to be present in many different markets. As I say, Italy is an example of a country which has large economy and is behind the development in data center to even to Spain, to in particular France, Netherlands, Germany. So there will be investment there because there is still demand for cloud application, demand for sovereignty in data. So AI model that can be run and developed by national champion. So I think it's not, and most probably the train data center can be placed in an isolated location, but for inference, for cloud application, for neo cloud, the financial centers will be still a big attractor. So most probably what happened at the region of Frankfurt, which is maybe 20 kilometers around Frankfurt, is already at full capacity, but we will see more growing in a sphere around, in a circle around Frankfurt, but this demand in Frankfurt, in Paris, will continue to be there. So and again, there are different policymakers. We have the European, we have the national, and we have also the local authorities, which will have a say if and when the data center can be built in a specific area. So it's a complex game, but I think a solution will be identified, and I think policy will be supportive for growing this industry in Europe.
Okay. And the last question is, as Europe accelerates grid and data center expansion, how do we ensure the green vision isn't sacrificed for speed? And what role does policy play in keeping both goals on this track?
As I said, the policy should be an enabler and should be facilitators. But as I say, some public funding could be available, but it's not enough at the investment needed. So I think what is important is to attract private capital investor. Creating another point that is very important to note is that we don't have a big champion in Europe. We have some growing company. Mistral in France is one of them, but we want to create more of this company that can create jobs, can attract and develop knowledge and capacity in Europe. So all what is the soft support can be driven by policies. As I say, not only European, but it's important to look at national policy and even regional policy. But again, this development will happen driven mainly by private capital, by investors, by company willing to play their role. And I think also the energy, and in particular the electricity player, will have a big role to play, because in the end is their area of this expertise. They know the solution. They've been contributed to creating a network for the distribution of electricity, which is already very solid. Of course, not anymore up to the request increase, but certainly on that side, Europe has a lot of knowledge and expertise that can really support this expansion.
Okay. Thank you once again, Paulo. We've started today from the policy perspective, looking at the long-term vision, regulatory priorities, and strategic direction for Europe. So our next speaker brings a different but important perspective, the transformation of the power system itself. We are delighted to welcome Mark Benayoun. Mark is advisor to the chairman and CEO of EDF and chairman of the board of the Edison, Italy's third largest energy company, with more than 3 decades of experience across banking, consulting, and energy. He brings a unique perspective on electrification, system flexibility, and the future evolution of Europe's power sector. And today, he will share his insights on from stability to flexibility, the next phase of Europe's great evolution. Mark, welcome. Over to you.
Oh, good morning, everyone. I'm glad to spend a couple of minutes with you to talk about this very interesting issue. Okay, the evolution of the electricity generation at the EU level. I just would like to remind you that the power consumption is going to grow in Europe. The total energy consumption is going to go down, but the share of power is going to increase, and that's a result of the net zero objectives. I'm not sure we get exactly to net zero, but we are going to reduce very significantly our CO2 emissions. And this is painting a very interesting background for the data center introduction, because we know that as a result of the changing mix, there will be also a lot of flexibility need, right? Daily flexibility. Because of the solar PV and onshore wind do not match exactly, obviously, the demand, but also the weekly flexibility requirements. So we know that the system is already, before the data center, it is under stress, because we are going to use more power and we will need a lot of flexibility. Well, if we look at the distribution of data centers worldwide, we very clearly realize that it's a US driven industry right now. if you look at Europe, Europe and Asia are clearly lagging behind with 1/4, 1/5 of the capacity that is being developed and is already available in the US right now. I don't know if this is going to change in the coming years, but clearly in terms of speed of development, expertise, the US are pioneering this industry. And if we look at what is happening in Paris, as Paolo said, the new capacity that is being developed right now is Frankfurt, London, Amsterdam, Paris, and Dublin. And there's also some capacity in the Nordics, but the Nordic system is a rather small, in fact, power system in terms of generation and transmission. So while it is obviously practically emission-free because of the hydro, you cannot easily accelerate in this region because of the existing capacity available. The next slide shows you where we are going to see the biggest increase. Most likely, this is based on the FIDs of the various players and declarations. And as you can see, Germany and France are going to be very big players along with UK. The other players are slightly smaller, and it is of course related to the size of the power market. And I agree with what Paolo said. We would rather have data centers connected to the grid, so it takes a strong power system to host these. You can put, in fact, a data center anywhere with on-site generation, but this is going to be most likely gas generation because you need 24-hour service, right? So we know that this is the case in some places in the US, but clearly this is expensive and this is not clean in terms of emissions. Now let's talk about the constraints. One of the countries which has the largest base right now, we've already close to 20% of the power demand represented by data centers is Ireland. But as a result, the system is in such a stress right now that the government and the regulators have practically banned new projects for some time because they need to reinforce the system. So the access to connections and capacity is constrained. The projects are based on security of supply criteria, which obviously creates a very tall order. And there's a very strong incentive that has been put in place to force data centers away of the Dublin area. So that shows you that if one country which is developing very fast, or which has developed very fast, that industry is already suffering some significant constraint, and it takes time now to, I would say, to let the dust settle in a way, to reinvest in the power system in order to relaunch, because obviously Ireland understands the value of this industry. They are not happy with this situation. They would like to continue to be a leader, but there is the physical constraint that they are facing right now. Again, this one is interesting. The US right now, because of the size of the industry, is clearly the most constrained market right now. So we have moratorium, we have already very strong cost base allocated to the new project. Some regions or some systems like ERCOT say, well, if this is a large load, i.e. more than 100 megawatt, and we are talking now frequently about 1 gigawatt for a new hyperscale center, they want to assess in a very clearly detailed way the impact on the local transmission. So in a way, it's not exactly the situation of Ireland, but they already feel the stress and they are starting to constrain the new data centers. So clearly, we can see that with the growing power demand as a result of net zero, the additional stress created by this very fast growing industry is putting the systems into a very high level of constraint. Now let's talk a little bit about where we have less constraints and which power systems might be best suited to site new projects. Well, first, the reliability of the power grid is important, right? To have very few interruptions and to have a system that has been well designed and operated and maintained. No evidence of curtailment or even worse, blackouts, which was the case in Spain a year and a half ago. So this is important. The second aspect is the existing, the available electricity. I mean, the fact that there is abundant capacity in the region and that it will be possible to buy a lot of power without strong impact on the system and the prices. That's the second aspect. Third aspect would be the low carbon electricity. Obviously, this industry has a strong reputation to maintain. So this industry has a reputation to maintain, and they will favor the solutions which are based on renewables and nuclear, because they cannot be seen as a factor deteriorating or affecting the climate. So they want to use a lot of electricity, but at the same time, they need to claim that this electricity is practically carbon-free. That is key for this industry. And then obviously, this is a factor that will be paramount in the coming years. Stable and competitive prices, which is also linked to the existing capacity in the system. And of course, the reliable network and a quick access to the power grid. If we look at these factors, it turns out that France is well positioned on a number of them. First, the export capacity, and the fact that we have a lot of existing capacity now, and the power demand went down as a result of strong energy efficiency policies. Right now, France is the first exporter of electricity in Europe with 90 terawatt hours. So it means that developing new projects that would use up to 50, 60, 70 terawatt hours in France would not create a stress on the generation fleet. That I think is quite unique. In terms of reliability, France is also among the best systems, as recognized by all the industry experts. Carbon intensity is very low, with 22 grams of CO2 per kilowatt hour produced. So there is no need to engineer very complex PPA structure with the difficulties of the 24/7 requirements. There's a rather skilled workforce. We know also how to how to manage the power delivery. There are lots of companies like Schneider Electric, Nexsense, and others. So we have a very strong electrical capability and strong firms, including worldwide leaders. So all this is playing well and is creating an attractive context for new data center sites. What in fact is key, and I think that not everybody understands that, is the constraint on the grid. And I'm going to give you an example. If you look at the biggest sites in terms of capacity subscription in Europe right now, they are around 500 megawatt baseload capacity. If you look at a big smelter, that's what you need. And basically, these projects historically have been sited very close to generation capacity and high voltage transmission because they were I would say, they were so big and so complex to manage in the system. This is going to be the same thing with the data centers. And basically, I think that data centers today, they want to be close to the telecom network. They want to be close to the engineering capabilities or to academic centers. Basically, you want to be close to large towns, and that's not necessarily where you have the existing transmission capacity. And if we see here, we have here an interesting map, which was developed by Elia, which is the TSO of Belgium. And basically they say, well, we can accept new large customers rather quickly into the grid, into the Belgian grid, but this is only on the green areas. The yellow will be more difficult to manage, and orange and red, well, this is unlikely in the next 10 years. So I think that the constraints of the grid are going to be increasingly felt in the coming years, including in the systems where there is a lot of available capacity. And developing the connection is actually quite expensive. And a high voltage transmission in Europe is rarely developed in less than 3 years. You have the public acceptance issues, and the cost, how the cost is allocated between the new customer and the rest of the and all the other incumbent consumers, and so on and so forth. So I think that the grid constraint is going to be increasingly an issue, and will be a condition for the new sites. Then we get into the flexibility issues, and that one is I think is really neat and really nice. In the past, data centers were not a source of flexibility, and I strongly believe, if I look at the new projects that we as EDF are supporting right now, or even hosting on some of our sites, we realize that there are some levers at 3 different layers of flexibility that can be leveraged in a data center project. First, the IT load side. When it comes to GPUs and AI training, there is some shiftability. I'm going to present that, which means that you can ask the data center to stop or reduce the training, let's say for a couple of weeks, when the system in a year, right? For, let's say, this is something that is to be contractually designed, but you are going to tell them, well, you can use obviously your infrastructure, but reduce or limit the training for, let's say, 10, 15 days, and we will tell you a couple of days in advance when these days are coming. And for that service, we are going to compensate you. Cooling system also, because of the thermal inertia, are already being used. That's something that's well understood in the industry. And finally, the uninterruptible power supply solution, and that is really I think the changing factor right now, where we see some new, I would say, advancements, is the fact that we are moving from gensets, which are represented here on that picture, to batteries. And in fact, once you have a battery, you can support the power system frequency. So I think that frequency adjustment, primary and maybe even secondary reserve, will be provided by data centers with minimal capital adjustments in the future. So maybe the cost of the project will increase from, let's say, 100 to 102, 3, 4, 5, but in return, there will be a very significant compensation received by the developer in the form of cheaper power or ancillary services. And that, I think, is a very interesting changing factor. That is the impact of the new, I would say, the new data center age. If you look at the historical, which was transactional based, there was absolutely no shiftability. If you make, if you pay some service or product with Apple Pay, you want to receive a feedback from your bank immediately that the transaction has been conducted and in a way that is aligned with your expectations, right? It's the right number, the right price. This will affect your bank account, and so on and so forth. So it has to be available 24 hours a day, 7 days a week. If you look at the AI inference and web services, there is already some component of the load that can be shifted. And for the AI training, which is in fact a batch processing, it's even more. So as we move towards the most advanced project and with the highest capacity, typically 1 gigawatt and above, there is some shiftability that can be brought to bear, right? And that, I think, it will be key. The energy suppliers and the data centers operators, which understand that feature and which monetize that feature, well, I think will be the winners in the coming years. And that one is related to to the battery, I would say, opportunity. The full cost of the battery systems has been going down over the last year very significantly, and we expect that it will continue to go down and maybe reduce by practically a factor 30-40% in the coming years. So what does that mean? It means that in some systems where there is a very significant intraday volatility, you can already develop a BES system on a merchant basis. But if you need batteries for other reasons, and if you have a site equipped with a balance of plant, access to the grid, and so on and so forth, this is making the battery much more, I would say, efficient from a capital standpoint. So you are going to use, in fact, less cash in order to get to the same service. And for that reason, I think that PV, renewable wind, and data centers in the coming years will be ideal places in order to add battery capacity to the system and reduce the impact of these projects to the grid, or even alleviate the need for flexibility or provide flexibility services beyond what the data center is already representing. So that, I think, is very important. When we think of data centers, we see them as a constraint because we see how they were developed. I would say with a time to market focus in the US, without batteries, with on-site generation, with a lot of water, i.e. open cycle, not closed cycle, water cooling system, and so on and so forth. But with minor adjustments in the coming years, I think that we will be able to use these systems as a resource, in fact, to the power system. And that will be my conclusion. We should not be afraid of data centers. With minor adjustments and efficient policies, we will be able to host them in the European power grid very effectively. Thank you.
Thank you, Mark. Thank you. I particularly enjoy your perspectives on how Europe's grid is evolving from a system designed around predictability towards one that must increasingly manage complexity, variability, and flexibility. And I also like the model you gave to us. You showed that the IT load modulation, battery management, and use UPS batteries to support grid flexibility. That's excellent. And we came across a Reuters report recently about EDF expanding its long-term power contracts, offering more price certainty to large industrial consumers. And we've actually seen this is in action. EDF signed a deal with Data4 last year to supply low carbon electricity to their data centers in France. But at the same time, your Keynote is emphasizing the flexibility. So how do you balance the two? How does a utility like EDF offer the long-term stability that consumers want while also building the flexibility that the grid needs?
Well, the contracts that we offer are basically power purchase agreements. And instead of renewable, well, we also offer renewable PPAs, but this is not I would say, the unique feature of EDF. What is quite unique is the fact that we can offer long-term contracts based on nuclear generation. So this is not exactly a fixed price contract, but it's close to that because the cost structure of nuclear is really fixed. So it will depend on the availability, cost of uranium, and a couple of other stuff. But basically, it's going to move in a very short window. The flexibility, in fact, is going to reduce the cost of all the other components, transmission, and also it is going to allow the data center to make money because of this shiftability or the use of batteries and frequency adjustment. So the base load will have a cost which is X, but instead of paying more because you create a stress on the system, you will receive money because you are offering flexibility services to the system. So it's absolutely compatible, right?
Yes, yes. Okay. So if you had to identify the single biggest lever EDF could pull to accelerate Europe's great data center integration, what would it be?
The fact that it's in fact the connection to the grid. We have a lot of companies in France which have applied to capacity and grid connection, and therefore there is a long queue of projects, and this is creating significant time to market and also uncertainties on the firm capacity that will be delivered. So, for instance, the RTSO, RTE will say, I can connect you to the grid, but you will have the full capacity only 3 or 4 years down the road. You will have to pay for that. And there's a risk of interruption because they look at all the projects as if these projects were going to be developed. And that's not only data centers, it's also industries and other projects. And so this is creating, I would say, an uncertainty for the data center developer that is difficult to manage and to understand. So while we have a lot of capacity, generation capacity, the access to transmission, firm capacity and connection is actually quite complex and costly. So, and they have created a fast track concept, but fast track is 3 years instead of 5 or 6. And in the US, they develop data centers in 2 years, right? So I think transmission is a bit lagging behind, but that's the same in all the European countries because we all operate basically along the same lines, right? And in the US, I think they focus on speed, but they create a lot of stress in that system. So it's a different approach, right? It's less managed, I would say. So the prices are going up. The flexibility requirements are very difficult to manage. Here in Europe, we tend to bring new customers to the grid in a very, I would say, risk-adverse way. So this is creating time, but at the same time, the projects are much more secure.
Yeah, thank you very much, Mark. Thank you. So far, we've explored the conversation from both the policy side and the energy side. So as AI adoption accelerates and digital infrastructure expand across Europe, data centers are becoming one of our most significant sources of the future electricity demand, just like the Mark said. So, and increasingly important partners in the energy transition. Considering of the time limits, we need to move to the next speaker. Thank you very much, Mark. And our next speaker is Neil Kalita. Neil Kalita serves as the Senior Director of Power and Energy Management at Entity Global Data Centers. He leads the team overseeing power procurement, closed-loop grid operations, and the company's goal to reach 100% renewable energy by 2030. He has more than 20 years of experience in real estate, energy investment, and project development. Today, Neil will discuss demand at Catalyst, how data center integrate with Europe's energy system. Neil, thank you for joining us. The floor is yours.
Great. Okay. All right. Well, everybody, I'm here to talk about demand as catalyst and how data centers will integrate with Europe's energy system. I think the first area I want to cover is the impact of AI and what does that actually look like. And effectively, we're moving away from or moving towards what was once cloud data centers, where we focused on the capacity of the data center with a high availability and a speed to market focus. With the AI gigafactories, it's a focus on compute, looking at the stability of the grid and the speed to power. The impact of AI will have quite far-reaching influences, not just in this energy system, but also with this presentation. When you look at that transition, what does that actually mean when you look over the data center power and energy? So from a data center and power, it's about stability within the grid. And here we're talking about how the grid and these gigafactories respond to the AI pulses that are created, which is an increasingly more volatile load than the cloud data centers. So we're looking at various technologies and management techniques to ensure that these AI pulses don't create instability in the grid. When we look at power and energy, it's about availability, and fundamentally, as alluded to by two previous speakers, the on-site generation solutions to facilitate that speed to power focus. And then when we look at data center and energy, we look at the capacity of how the space is being used, and more importantly, what we call utilization. So hopefully that gives you a context into some of the impacts of AI. And all of that combined to actually deliver compute. And that's an important distinction to make between capacity and compute in the way data centers operate, particularly when responding to AI loads. The challenges that we face, I always ask a question, what's the difference between power and energy? Sounds like an obvious question to ask, and there's no right answer, obviously, but what I'm trying to do with this slide is try and explain the differences, and the key overlap between the two is that concept of utilization, which I refer to as the hidden dimension. So when we look at power, it's about capital expenditure focused on infrastructure, and it's usually spent at the project level. One of the key challenges that we face is speed to power, largely due to the grid network operators struggling to keep up with the speed of development that we are and the scale of development. And I think when you boil it down into the specifics, the key point is that power is no longer about what we call day one. So gone are the days where we could apply for a 100 megawatt grid connection and get all of that capacity on day one. As alluded to by one of the earlier speakers, these connections are being phased. So we're getting our capacity over a period of time. And what we're also starting to see is that the connection agreements themselves are increasing in becoming more onerous. And a lot of that is around areas such as utilization. How are we going to ramp into our power capacity that we've got from the grid? How are we going to use that grid power? And then also, when we bring in alternative generation, how will that interact with the grid, and will it operate either in islanded mode or grid connected mode? So that's the key challenges that we look at specifically. When we look at the energy side, it's more about an OPEX for us, and we're focused on the commodity. And it's an operational spend that we have to do. And the challenge is how do we decarbonize that, make it lean and green, so become more efficient and more effective from a green, renewables perspective, and zero carbon targets. The specifics that we are seeing from an energy side of life is energy price inflation, which due to the geopolitical context is incredibly volatile. And hopefully calming down, but is on an upward trend. As we nearer towards 2030 and 2040, we are going to see a lot more competition for renewable energy PPAs, not just from other data centers, but also from industry as it looks to decarbonize. And how does that impact the operational interaction of our data centers? And fundamentally, what we have to look at is an integrated energy system. And then when we look at utilization, basically it's a percentage figure of how much is the client consuming versus how much they've contracted from us. And the challenge we have is what we call ramp versus PUE. So ramp is how does the client grow into their capacity? How do they use that capacity? And what impact does that have on our system efficiency, which is measured by the term PUE? Some of the specifics that we see is that associated with utilization, and as alluded to about the owners agreement, we are seeing that the ramp is specified in the connection agreements. So in France, that's becoming RTE as part of the CRE has now requiring new data centers to sign up to a prescribed ramp increase of the megawatts that they consume over a period of time. And then another thing that we're seeing as part of the phased connections is what we call utilization thresholds. So let's say we have 100 megawatts and it's parceled up into 20 megawatt chunks. So we'll get 20 megawatts on day one, and then to get the next phase of 20 megawatts, we have to show that we're at a certain level of utilization before that capacity is released. And so forth. And that presents a number of challenges for us in terms of the construction build-out rate, and also working with our clients to ensure that their utilization hits that threshold so we can get the next phase of power to build out the campus. And then the ultimate kind of stick that the network operators are using are called use it or lose it. This is quite a new concept in Europe, and we've not actually seen it executed anywhere in Europe, but we do know of some anecdotes of certain connections in certain locations with certain operators where the network operator has actually reduced the overall capacity of the data center in the connection agreement due to consistent low utilization. And that's why I call utilization the hidden dimension, because ultimately how we use the power in terms of the demand profile and how much of the power that we use in terms of the energy consumption is all driven by utilization by the client and what type of load they are doing, whether it's a cloud or an AI implementation. So when you look at the overall picture, I think the previous speakers already talked very eloquently about the kind of context as to why, but this is hopefully giving you a bit of a commercial reality of what we data center developers are having to deal with on the other side of it. I think coming up to my final slide, when we talk about Catalyst, it is about an integrated energy mix. So when you look at the data center from a grid side, one is we're starting to see a lot more of these flexible connections being offered, which it's basically offering a speed to power, but with conditions. So what we're seeing is certain conditions like you can get your power up to a certain level of utilization, and above that we will be constrained. And whilst those are appealing to a certain degree, they are commercially difficult because our clients do not want to be constrained by the capacity that they want to lease from us. So, for example, if I had a data center with a 20 megawatt grid connection, but was on a flexible connection of, say, 15, and I leased that 20 megawatts to the client, I would say I'd have to say to them that they can only ever reach a 75% utilization before there's no more power. And some clients are open to that, but with AI loads, it's very difficult because of the volatile demand and also the energy demands and needs of different AI loads are still being understood. So it becomes quite difficult to plan and forecast those. Then from a data center perspective, we are seeing a lot more offers of flexibility or demand side response. And I think it's important to make a distinction between the two because they're not linked, obviously. So flexibility is an interesting challenge and opportunity for data centers. At NTT, we already respond to a number of demand side response mechanisms under the Voltus program. So last year during the storms, we actually helped stabilize the Virginia grid by coming off the grid and running on our gensets for a couple of minutes and hours to allow that stability and frequency response. So we do and are able to turn up to flexibility. But the biggest challenge we have in Europe is that basically what's happening is that it's a misalignment between the permitting of our emissions as a data center and then us turning up for flexibility responses, which aren't part of that environmental permit. So we find ourselves at odds with legislation, which kind of gives some context as to why data centers aren't always signing up to these flexibility programs at the moment in Europe. So I think there's greater alignment that needs to be done there between the network operators, the grid regulators, and the environmental agencies that issue these environmental permits that set the number of operational hours that we can run on data centers on diesel generators. And it would be good if there was a carve out where if we turn up for the grid and stabilize the grid, it isn't part of our allowable hours under the environmental permit. I think it's important also to note that we do see flexibility as an important mechanism that we'd like to get more involved in because we see it as part of our secondary or maybe tertiary way of us meeting our service level agreements with our clients. We have high availability requirements. We call it the 5 nines, which when you boil it down means we can only be off for 20 minutes a year at the highest level. And if the grid goes down through no fault of our own, then that obviously eats into that 20 minutes. So by turning up in the flexibility mechanisms, we are actually meeting our SLAs by providing that grid stability. So there is a good context for it, but I think there's a slight misalignment in some of the regulatory aspects from the environment to the emissions, as I alluded to earlier. When you look at the gas side, and as already commented, there is a dash to gas. It is the only fuel at the moment, alternative fuel, that basically offers the firm capacity that we require. And so that gives us the speed to power that we require. But it's not just simply building a gas power plant and plugging it in and having speed to power, because the use case of the data center varies. So the two terms that we normally use are called bridge and prime. So bridging is basically sort of a mid-term term of, say, 5 years, 3 to 5 years, where the gas provides the power whilst the grid is built out and phased up. So that bridging solution, and then prime is where there is no more capacity available from the grid, and so the gas becomes part of the an overall energy supply in addition to the grid capacity that we have. So at NTT, we're always looking for scenarios where we can do bridge and prime. But more importantly as well, when we talk to gas power plant developers, we're starting to talk about concepts that came out of the battery world about revenue stacking, and how can that gas power plant not just serve the data center, but potentially act as a gas peaking plant for the grid. And then potentially over time, as the data center gets built out and the grid gets built out, the gas power plant could actually become our backup generation and replace the diesel generators that we sometimes place. So that's all in the conversation and adds to the complexity of from a commercial sense of the signing up and committing to a gas power plant. It's also important to note that there's different technologies out there. So there's a lot of gas engines and gas turbines, but I think the one that's getting a lot of attention right now is solid oxide fuel cells. Fuel cells are very interesting for a number of reasons. Partly, one part is the lead-in time. They're a lot more available because a lot of the OEMs that develop gas engines and gas turbines are fully sold out. And so the lead-in times on those are extended more than normal. But the really big win with fuel cells is in certain locations, in certain markets, the fuel cell is considered a chemical reaction rather than a combustion reaction. And so the environmental agencies in those locations don't actually require an SOF, a fuel cell power plant, to require an environmental permit. That's quite important for us because obviously it speeds up development of that power plant asset, but also it means that we're not cumulatively adding to our emissions from the diesel gen sets and our allowable hours under the environmental permits that we operate in as well. So fuel cells are very, very interesting. And then the green side, so sourcing renewable energy. So that's getting the zero carbon supply that we need through PPAs predominantly. I think from our side as a data center developer, we also see that we're a catalyst for investment, particularly in nascent markets where renewable energy is just starting and the deployment isn't as widespread or as mature as, say, Europe. So in those territories, we can definitely see that our demand is driving the real renewable energy developers to build out more generating assets based on the PPAs that we're prepared to sign up. I would like to talk a little bit about 24/7 carbon-free energy. I think it's a very interesting mechanism, but from our perspective, I think it's got a bit more way to go as a concept, as a commercial solution for data centers and for the renewable sector as a whole. In that we see ultimately the 24/7 carbon-free energy, when done properly and evolved from where it is today, could actually start to create the liquidity in the renewable energy space that we need, so that you can buy the renewable energy according to the time frames. Very similar to the way the electricity markets are currently structured. So, like day ahead spot, quarter ahead, season ahead, etc. So when we get to that stage, I think 24/7 carbon-free energy will become almost, it will provide that liquidity that the renewable energy sector, we think needs. And that, in essence, covers off the three Gs, if you will, the integrated energy mix that data centers now need to consider, not just in terms of the increasing complexity of where and how we get our power and buy our energy, but also how we respond to those different systems. And it's worth noting that, you know, when you move from America to Europe, to the Middle East, to Asia, to the APAC in India, they're all at different stages of deregulation and maturity, and there is no, in Europe specifically, what we would look for is closer alignment between the network operators about how they would alter their grid connection agreements to ensure that we, increase our utilization and allows them to manage. So, the utilization threshold, some consistency would be very useful, as well as the mechanisms for either penalizing or promoting data centers to increase their utilization so that connection capacity is utilized to its maximum. I think gas is going to be, as I said, the dash to gas, the main fuel supply for a little while yet, until we get potentially SMRs. But we also like the idea of thorium reactors, which is obviously represents a bit of technology risk. And then renewable energy plus storage is also a very, very useful solution. But to be able to co-locate them next to a data center, I think the land area that a solar plus storage solution would be far greater than a gas-based, and that power density of technology has to be considered as well as the firm capacity that data centers need. I think the volatile loads of AI, as we understand it, as we get to understand it better and we see more of it, I think the opportunity to optimize it will come, whether it's creating different types of exchanges of compute to maximize utilization, or alternatively looking at more flexible connections that allow for certain peaks to be hit without penalty, and then the grid to benefit from that lower utilization for the block of time that the AI doesn't need it. I think we're also in a really interesting world where the pace of development and the scale, where in North America we see a lot more gigawatt campuses, and in the UK, in Europe, I think we're yet to see one. I think there are a number of constraints around policy and regulation in Europe that would probably prevent a gigascale campus being built. But then the question becomes, do we actually need it if everywhere else has the gigascale for the learning aspect? And I think the really interesting market where Europe could take a lead is in the inference. I think that's been that was mentioned by one of the speakers earlier, and I think that is a really interesting typology that we have to look at. And that will obviously drive a different scale of data centers, probably a lot smaller, but a lot more in terms of quantity to provide that zero latency that inference models will need. Just circling back to grid a little bit, how we deal with the AI pulses. I think the data centers and the way that we build our power infrastructure will need to change, and we'll need to work in close concert with the network operators, specifically around how we deal with the AI pulses and prevent them hitting the grid. And we're already seeing some of our AI clients actually specifying certain types of technology. Some are AI-based, some are hardware-based, where they're able to mitigate some of those pulses and then also facilitate some of that flexibility on the demand side response. So yeah, it's a changing market. It's changing very quickly. And I think it's actually a catalyst for investment, as again, one of the speakers spoke about, on a number of fronts, as I hope you can see here. So we are prepared to invest in the grid and work with grid operators and regulators to ensure that the grid is future-proofed not just for data centers, but for the low carbon transition. The investment that we make can actually facilitate a quicker build out of the grid if we're allowed to. I think gas is still going to be there, but the most important thing about these gas solutions is not just a short-term and mid-term perspective, but also longer term. How does it capitalize? For example, in Germany, with the hydrogen economy that's being invested in, fuel cells and gas to a certain degree, will be able to accommodate certain concentrations of hydrogen, which could then help as a catalyst for that demand for hydrogen and support that economy of hydrogen as a commodity. And then, as I've alluded to already, in the renewables, I think we want as much zero carbon supply as we possibly can. We are an investment catalyst for new generating assets, and hopefully we can be part of the narrative to help mature the whole renewable space, to increase the level of liquidity, so that not just data centers but every user on the energy system, future energy system, can eventually move to zero carbon supply. Thanks very much.
Okay, thank you, Neil. Thank you. That was fascinating perspective from the demand side and a powerful reminder that data centers are no longer simply consumers of the electricity. They are becoming increasingly important participants in energy ecosystem. Yeah, and considering of the time limit, so we could only ask you about one question. And from the Q&A box, we can say the question from the Murad Jill. He asked about questions to Neil. How do you say entities IOWN technology changing future of data centers architectures? For example, enabling distributed data centers, remote GPUs, or new locations closer to renewable energy source.
Yeah, that's a great question. So IOWN is a new fiber technology that NTT Japan has developed. And we are interrogating it very, very closely, precisely because of those benefits that have been alluded to, which is that because of its reduced latency and energy efficient and energy consumption, IOWN could allow a more diverse range of locations to open up beyond what we call Tier 1 in Europe, which is FLAP-D, Frankfurt, London, Amsterdam, Paris, and Dublin. So IOWN is really potentially a game changer. And whilst we're on it, I think it's also worth mentioning photonics and quantum computing. So NTT is also very heavily invested in developing that technology. And I think we will see an evolution of what we call hybrid data centers, which is a combination of both standard data centers as we build them today with GPUs, and then potentially an element of quantum computing next to it or within the same building. So there is a case that, as the GPUs increase in density with AI, and then the speed and efficiency from IOWN and photonics could, really create a new type of data center product. And whether that sits at the LLM or the inference level is still to be determined. But it's IOWN. We're super excited about IOWN.
Okay, thank you. Thank you once again, Neil. We've heard today from policymakers, energy system leaders, and digital infrastructure operators. So to conclude our keynote session, I'd like to bring in a broader market perspective. And thank you again, Neil. Our final speaker is Christina Rintel. Christina is research lead at Aurora Energy Research, covering the French power markets with a background spanning power market and analytics and project finance at Bank Sabadell. She brings a sharp market perspective to today's discussion. So today she will deliver our closing keynote, dialogue and coordination, building a joint pathway for grid and data center expansion. Christina, welcome. Over to you.
Okay, perfect. So thank you, to Impact for the opportunity to speak today. As we mentioned, I'm going to be talking about specifically how to prepare the grid. I'll actually be doing a little bit of a deep dive on Spain, which we've mentioned a few times, has had some issues with its security of supply in recent times. But first, just allow me very, very quickly to just kind of give a couple of words about Aurora for those of you who don't know us. So we're a global provider of power market analytics, and that means power market forecasting, but it also means everything that comes along with that and related to the system, including grid congestion, obviously storage, renewables, PPAs, and of course, demand forecast. There's over 1,000 market experts spread across the globe, and you can see on the map that actually a lot of them are based in countries where data centers are becoming very, very relevant. So it's obviously something together with the grid work that we've been doing that has been at the forefront of our analysis, and we've been asking ourselves a lot of questions about this recently. So on to today's session. I wanted to touch on how much data center demand will there actually be, and what does that actually mean for the grid in itself, and when you're forecasting and trying to assign investment to the grid as a TSO. What are the best regions, not just across a country or a national perspective, but also within a specific country. We'll look at Spain as an example there. And what actually are the technical barriers to doing that? So we saw a lot of slides from my previous panelists on the projection of data center demand. I wanted to come at it from a little bit of a different direction and just highlight, actually, there are so many forecasts and they vary quite a lot of data center demand. I'm just showing here a few samples, and it's actually from almost a year ago. So it's probably not even it's probably a lot wider the range if we were to take all of these figures now. And what I want to say here is, if you are trying to plan a strategy as a TSO around grid connection or developing out the network in order to absorb this demand, it's really difficult to actually understand what you need to do. And that is actually leading to some of the situations that we've heard, especially in France, for example, of limiting connection capacity at the beginning in order to kind of expect that this could increase, or, you know, applying restrictions on the demand side to allow for that flexibility in the grid, because otherwise this just becomes quite unmanageable, and you could really end up with some difficulties in the future if you haven't kind of planned for the upper bound potentially in the growth of data center demand. We discussed about how data centers obviously want to locate where they can get fast grid access and firm, cheap green power. It's also really important to have, you know, obviously connections to, you know, maybe potentially if we look at Portugal, connections to undersea cables to the US. So having that kind of good fiber, you know, cables network, having access to PPAs potentially, so a liquid PPA market, or, you know, that clean power. It doesn't necessarily have to be green. It can be nuclear as well, low carbon. That's really important. But of course, you want to locate where you can actually get online. And so we already discussed a few of the countries where, you know, this is a challenge, or you know, even in the US, if we look at some areas where it's actually relatively quick. So that means that those countries which do have a lot of congestion in terms of grid connection requests, you really need to start looking to other locations where you can get on. But of course, then you need to start thinking about the question of the power, of whether you're actually, you know, is it a good location in terms of everything else. So we mentioned a few of these countries. Ireland obviously had a big push. Now we see almost a kind of a pause in development there. Spain grid queues are fairly low compared to maybe some other countries, but of course, as we said, we've had some issues with the network, although it does have a very liquid PPA market. France is very well positioned in terms of its strategic kind of the cabling hub that kind of go to the rest of Asia, or even the rest of Europe and the US. So you do need to be able to get your grid connection, and that means that the network does need to be ready to absorb all of this demand. And it's not just data center demand, of course. This is coming with all forms of demand. Of course, the let's say issue with all AI-driven things is of course the pace. And so again, it is very difficult when you're having very long investment cycles as a TSO to relate that to the kind of boom, let's say, of AI and then data centers coming behind. So what does that mean then if you then look at a specific country? So we're just going to zoom in on Spain. So of course, as I mentioned, it's not just a case of citing the country that you want. Within the country, you need to also think about what is actually available and where you would actually be located. So this is just a very quick map of Spain. These are some of the data centers in the pipeline that we actually consider in our forecast through 2035. You can see that there's a big kind of hub in Madrid in the center and also in Barcelona on the east coast. And so this kind of has the logic of, the big cities hosting the internet exchanges. Once you have the hub there, it's kind of easier. It can be easier to connect. But you also see quite a big pipeline in regions like Zaragoza, which is kind of just in between those two big cities. I don't know if anyone here has been to Zaragoza. It is kind of it can be attractive in the sense that it is basically surrounded by desert. So there's a lot of physical space for development. It has a very high solar resource. It is also quite windy. So it's really good for renewables. And so these types of cities can be really interesting in terms of deploying data centers. However, if we actually look at where the current demand to connect to in Spain is located, this is what this map is currently showing. We can actually see that those locations actually don't coincide at all. So this really shows that kind of in regions where, again, you would have quite a lot of space, you would be located to big cities or the infrastructure is already there for data centers, there actually aren't any available demand access points currently in Spain. So this mismatch between the grid and where ideally as a developer you would like to invest is quite stark here in this example. I just touched very, very quickly on kind of like the grid connection point. So, there's a few ways that Aurora can help with these things and other aspects that, of course, are really, really important to consider. So in terms of the siting, it is where can you connect and how fast? And I think it's really important to start looking at these things on a nodal basis. You really need to understand whether you are getting a firm grid connection. Will you be curtailed? Will you be curtailed? If you've got some flexibility, will you be curtailed on the generation side, on the demand side? For how long, during which hours of the day? How will that actually impact your business case? Really, everything in the power system is now happening not even hourly, but quarter hourly. So it's really important to look at that in a granular way. It's important to understand, how important is being green? What is your power procurement strategy? What does the structure of your PPA look like? What does that look like if you have, a co-located asset? Obviously, in potential imbalance costs. What is the sizing of any, renewables or even, gas, even potentially? How much power do you actually need for your data center, both now and in the future as your potential grid connection evolves? And also, it's important to understand, will you be charged actually any tariffs, or will there be any kind of, let's call them non-wholesale market costs? So you may have a PPA that reduces or, at least means that your power will be predictable as you need. But what about the power costs or the connection costs or the non-wholesale market costs? They can be quite significant in some regions, and it's also important to make sure that they're considered in the business model, especially if you're considering some kind of flexibility. I thought that that touching on the flexibility previously was very interesting and definitely something to consider in the business model. And again, if you have some kind of behind the meter structure, you can potentially optimize this structure of the grid charges. And of course, you know, at Aurora, what we're looking at here is, again, the nodal impact and kind of really looking at a granular project by project basis of exactly how you can optimize all of these things, given the context of the specific market that you're in, because as we've mentioned, it changes so much across all of those different markets. So just to sum up, I think it's probably summing up exactly what we've been saying throughout the whole of the presentation. So it definitely is the connection point rather than the generation side. And especially if we look at a country like Spain, we've just come from 9 gigawatts of installed utility scale solar in the last year. So renewable generation is definitely not the problem, but that does put strain on the grid. And it can actually put off, you know, potentially the development of data centers or new industry in general deployment, given the lack of grid availability or even restrictions on the operation. That constraint is physical. Quite often it's a case of literally transporting the energy across the grid. And it's not the same throughout every country. This can show up in different areas of the grid. And especially when you have nodal markets or you have very popular areas that kind of everybody wants to be in, the wait times can vary enormously across different areas of the grid, node by node. So it really does need that nodal grid modeling is pretty essential, or at least looking at this on a granular level, both in terms of the connection, but also what happens afterwards. So kind of the strategy around power procurement. So yeah, thanks everyone for joining in the opportunity. I'll leave it there. I know we were a little bit tight on time.
Thank you, Christina. And your presentation highlighted just how interconnected these challenges have become, from power market development and infrastructure investments to digital growth and long-term planning. And I find a very interesting point, both you and Mark, you mentioned about the problem of the access to the grid. And, you know, looking across Europe today, new data centers in major hubs can face grid connection waits of 7 to 10 years, just like what you mentioned. And on top of that, forecasts for AI-related power use vary a lot. So where do you see the biggest disconnect between the long-term infrastructure planning and the path of the AI-driven demand growth?
Yeah, I think it's exactly that. I think it's there is a speed to the kind of AI boom, as I said, that I think is a little bit unprecedented. You know, we're a little bit, maybe everyone who's in this industry is a little bit more clued into it, but I think there's kind of it's hard to appreciate how fast this world is actually moving. And so we do just see a scale and a speed that is just being slowed down by a kind of just a different investment timeline when you come to the grid. And, you know, we're talking about data, you know, we're literally talking about data centers, but a lot of the times there's a lack of transparency of exactly where those available grid connections are, how long is it actually going to take. So a lot of TSOs are actually doing a lot of work just on the transparency and getting the existing knowledge that they have out there to those people so we can actually make decisions in a timely way. So I think it's just this disconnect between the time it takes both to plan those investments and actually realize them compared to how fast the AI kind of revolution is happening.
Thank you, Christina. And considering of the time limit, we only ask you just this one question. So thank you again, Christina. And thank you to all of our keynote speakers today, Paulo, Mark, Neil, and Christina. Your insights have made for a truly rich conversation, I think. And what strikes me most from today is that for a long time, you know, energy and digital infrastructure were seen as just like separate words, one physical, one virtual, And what today has shown us is that the distinction no longer holds, and the grid and the data center are not just connected, they are codependent. And Europe's ability to lead in the age of AI will depend entirely on its ability to recognize that and act on it together. So I think that's not a small shift, it's a fundamental one. So that brings us to the end of today's session. A huge thank you to all of our speakers for sharing your insights. And thank you for everyone in the audience for joining us. A reminder that the recording and recap will share within a week. Just like I noticed that in the chat box, somebody asked whether it is allowed to download our PDF and PowerPoint. I think, yes, sure. We will upload these materials about just 1 week. And if you have any comments, please feel free to drop me a message at the below contact. Okay, the conversation doesn't stop here. It moves to Frankfurt. And at the summit in September, these questions will be taken further with more voices, more depths, and decision makers who are actively shaping Europe's energy and digital future. So we hope to see many of you there. Thank you all of your time and your questions and your engagement today. It's been a genuine pleasure hosting you. Until Frankfurt, take care, everyone.